Hi everyone, I am Lalit and we'll be discussing a few questions based on week 4 lectures. Okay, I guess you people can see my screen.
Yes, sir.
Okay, okay, so here's the first question for the day. So you are given a plane induced homography of a stereo imaging setup. So what does this mean? We have a stereo setup out here. That means we have two cameras given to us. These are the image planes of camera 1 and camera 2. Which is camera 1, camera 2, and we are given a plane induced homography. That means there was a plane in the scene. Okay, and we have camera centers somewhere here, which I would like to call as C1 and C2. Okay, or maybe I'll just stick to the lecture convention, so that would be better. So this is C and this is C prime. Okay, so we are given epipole E prime in the right image plane. What is an epipole? Can anyone tell that?
So the projection of point C to the camera one, point C to camera two, and vice versa also. That would
Yes,
be
yes,
the
yes. So the projection of camera center of the other camera onto the current camera.
yes, sir. Yes.
Yeah, that's the epipole. So here we are given epipole of the right image plane. That means if we try to draw a line, if we try to draw a line like this, okay, doesn't seem like a line, but anyways. So if you try to draw a line like this, it will intersect somewhere here. So this intersection is E prime and this intersection is E. That means you're trying to image the other camera center. That's all. Okay, so we are given E prime. E prime is given as 351 in homogeneous coordinate systems. This is okay. And a point 2 comma 1 is given in the left image plane. So there is another point x, which is again we would like to write in homogeneous coordinate system as 211. So compute the epipolar line L prime on which the corresponding point x will lie in the right image plane. Okay, so just for a recap, I hope you are clear about this thing that if there is a plane in the scene, so this will have a homography. For instance, you can say it as h1, and this will have a homography h2. So net between these two image planes also there will be homography h. Okay, so yeah, can someone try to answer this question? So the hints here are that we are given an epipole and a epipole in the right image and a point x in the left image.
So will it be the projection matrix into the epipole to get the line, epipolar line?
No. What is an epipolar
We need
line?
to take the cross product of epipolar line and x. Sorry, epipole E prime and x.
Okay, are you sure about that?
Sorry, the skew symmetric matrix of E prime with X.
Okay, 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 fine, fine. I think you are slightly confused. Okay, what is epipolar line at first place? If you're clear about that, then this question is pretty simple. That's why I'm trying to dot diagrams here so that if you visualize it, it's easy to remember.
Is the line joining from the epipolar point to the epipole to the image of the point X. That will be the epipolar line.
Okay, okay. So I will just try to give you a geometric uh, interpretation. You are right, by the way. So if you have some scene point X, and this whole thing is a plane, right? C prime X is a plane, and these are also image planes.
Just a confirmation. Can we consider the image plane as a image, real image?
Image plane is a real image, but here image plane, when I say image plane, that means it extends up to infinity. It is not limited by any sensor or something. So we are
Okay.
mathematically saying it that it extends up to infinity. It's
Okay.
not.
So it's like in some devices the pixels will be varying. So we'll consider like we'll solve these problems all through a general, right?
Yeah, yeah, yeah. So we are not considering any dimension of this plane.
Dimension of
We are
okay.
assuming
So
that
if
it's extends to
so
infinity.
whatever photo we click will be falling on this image plane. So it's almost similar. Like it's the photo only, right? Like
Yes, yes.
whatever
It's
photo
the
we take,
photo. Yeah, exactly. It's the
but it
photo.
is infinite here.
Yeah, yeah. Here we are assuming that we have infinite size sensor somehow,
Okay. Thank
just
you.
for mathematical purpose. That's all.
Yeah.
So yeah, so this C prime, and X form a plane. So this plane and this plane, the image plane and this plane obtained by this capital X. Okay, so these two intersect at a point. So if I say that X lies here, this X point lies here. So here there will be a corresponding X prime. So the epipolar line will look like this. So this is the epipolar line L prime. So sorry, I'll just make it consistent. Yeah. So this is the epipolar line X prime. So it is the line which joins the epipole to the point where it corresponds. The 3D point is corresponding on the image plane. Okay. So I hope this how this what is the physical interpretation of epipolar line makes sense here, right? So similarly,
Yes.
we have a line here as well which joins E and X, which is through E and X, which is given as L in our notations. Okay, so fine. Someone said that we need to take cross products. So we can take cross products only on the points that lie on that plane, right? Like L prime. Okay, I'll just try to write it. Okay, that L prime is E prime cross X prime, and L is E cross X. Okay. So someone got confused here. They tried to take cross products E prime with X. So that's not how you create a line here. So now, given this definition of L prime that you are clear about, how can you obtain L prime given X, E prime, and H? What does H do? We are given a homography between two image planes, right? How can you make use of it?
We can convert the x point like to one. We can multiply h with x, and then it will be x prime. So x prime is equals to hx, right?
Yeah, exactly. So for what we need to do is X prime equals to HX, through which we get an X prime. and then we'll be able to find L prime, which is E cross X prime. So that's all there is to this question. Is this clear to everyone?
Yes, sir.
Okay, so I'll just write out the numbers. So this is a nice homography matrix. It seems the last row is 001. And what is X? 211, which gives us, write it here, is 4 minus 8, 1. So now we'll try to compute L is E prime cross X prime. Now by now you people would have known how to take cross products. So our E prime is 351. Yep. And our X prime is 481. Join. Okay, fine. So this leads us to this answer. Sorry, it should be L prime. Yeah. So this question is fine, right? Any doubts in this question?
Yes, sir. Fine.
Okay, yeah, great. Then we'll move on to the next question. Okay, so we are given a camera with calibration K that forms an image I of the world scene, and the camera is rotated by about its center R and then forms another image I prime of the same world scene. Okay. So if I and I prime form the left and right image planes of the stereo imaging setup, compute the homography between I and I prime. Okay, so the first thing is, does everyone agree that it will create a homography?
Yes, sir.
Okay, how can you say that? If you agree, then you should have a reason for that. Yep. How can you say that?
So the first camera will be having camera calibration matrix, and it is rotated, and so like from the first camera, like both cameras have same calibration matrix.
Mm-hmm.
So in since it is rotated, so there will be homography where we can.
Okay, so the first camera plane, or rather, first image plane will look like this. Then the second image plane will look something like this. They both share the same camera center. Does everyone agree with this?
Yes, sir.
Okay. Since there is only rotation, there is no translation out there. So the camera center is shared between image planes. Okay, that's great then. So given these matrices, I would like to first construct P. P is for the left one and P prime is for the right one. So my P will look like this if I assume that the camera center is at the origin. Okay. And my P prime will look something like this. Since there is no translation and only rotation, so it will look like this. So given a 3D point, X is a 3D point, how can we mathematically try to write it? So we first take the images of the 3D point. And this should be in homogeneous. Prime X. So this gives me ki0 x, and this gives me what, k r0 x. So if I'm just trying to derive the homography out here. This part is clear, right? Yeah,
Yes, sir.
yeah. K inverse. K is K should be invertible. It's the camera calibration matrix. So this K inverse, this thing is coming as x. So since we have a relation x prime is K inverse x, so this is the actual homography matrix H. Yep. So there's nothing much to this question. We just try to place this formula out there. K is given as 2.0. If you are given K like this, you will obtain K inverse something like this. And given this, we just need to find K inverse, which is, I'll just write out the matrices. Okay, so so what do you know about rotation matrices in general?
It rotates the plane for the camera, uh, keeping the camera center in a position if no translation is there. So camera center will be the same, just the rotation of the plane will occur.
Okay, that's good. Mm, if I ask you mathematically, how does a rotation matrix, how can you characterize a rotation matrix? Then can you say that? It's a linear algebra question for now, not a computer vision question. Of course, it rotates a point in the space in which you're working. That's fine. But anything more specific to that?
It is a matrix, like it is a transformation where we can keep the transformation in matrix using sine theta and cos theta.
Uh, okay, fine. I mean, in higher dimensions, you have to deal with too many thetas. Sine theta and cos theta is good enough for 2 dimensions. For 3 dimensions, you will have two parameters. Oh, sorry, three parameters. Sorry about that. And then higher dimensions, the number of parameters increase. Any more things that you know about the rotation matrix are? So in the question, it's given, somehow it's given that it's a rotation matrix, which looks like this. Do you agree that it's a rotation matrix?
So is it have to be a diagonal matrix?
Okay. Just by inspection, this doesn't look like diagonal, right?
Yes,
So
yes.
it's, well, okay. It's a valid rotation matrix, but can you give me a proof that why it's a rotation matrix at first place? I can write any arbitrary number, and it still, can it be a rotation matrix or not? Okay, why is this not a rotation matrix? And why is this supposed to be a rotation matrix?
Sorry, sir, no idea.
No idea, sir.
Okay, that's fine. Anyone else? Have you read about this property anywhere? The rotation matrices are
Yes, sir. Yes.
orthonormal matrices. What does orthonormality mean? If you consider any row Ri, if Ri is a row of R, then Ri transpose Ri, okay, I'll write it like this. Ri transpose Rj is 1 if I equals to j, 0 if I not equals to j. So this is the rotation matrices are orthonormal matrices, which means that they should satisfy this condition. Okay, so the dot product of two rows should either be 1 or 0. I mean, same row should be 1 or any other row should be 0. That's how the orthonormal matrices are defined. Okay, given this, can you now say that this is a rotation matrix? You can just try doing R transpose R and it will turn out to be identity.
Yes, sir. It comes out.
Okay, yeah, that's fine. So, yeah, that's the reason these are not rotation matrices. Only this is a rotation matrix, the middle one. You can see my cursor, right?
Yes, sir.
Yeah, okay, great. Okay, then just multiply the matrix and then we'll get the homography, which should look something like this. This is the final homography matrix. Okay, I guess this question is clear. It's pretty simple one based on the formula. Okay, the next question is a multiple choice type question. Okay, yeah. Assume that a stereo imaging setup has two image planes. So you're given again two image planes left and right. Which of the following could be a possible right null vector of the given fundamental matrix F? So we are given a fundamental matrix F like this: 28 minus 4, 0, 59 minus 177. Okay, seems quite complicated. Okay, properties of fundamental matrix. One of the basic property of fundamental matrix.
So
Can
the
anyone? Mm-hmm.
last row is the scaling factor.
Okay, that's for any matrix, I guess, even for homography
Yeah.
matrix. But what's special about fundamental matrix? There's a hint in the question, by the way. Right null vector. What kind of matrices have null vector? Okay, the one of the important properties of fundamental matrix is rank of F is
Rank. Oh, sure, the fundamental property rank of S is. I forgot the determinant will be zero actually.
okay.
Determinant of the
Okay,
matrix.
that means what?
So that I forgot the name. What is called rank deficient matrix.
Singular.
Rank deficient
Yeah,
matrix.
okay, it's singular, but so this implies what? Rank of F is less than 3, right? Because it's a 3 cross 3 matrix.
Yes, sir.
But in, I mean, you can have degenerate fundamental matrices, but in general, the rank of fundamental matrix is 2. Okay. Degenerate means the rank of F is 1 or even 0. 0 is anyways not considered, but 1 you can have special cases when you can have fundamental matrix as one. Okay. So with this given fundamental matrix, what do you mean by right null vector? Just from linear algebra, there is nothing specific about fundamental matrix here. Right null vector. What is right about it? Or is there something wrong about it? So given a matrix F or any matrix A, if A into V is 0 for V not equals to 0, that means V is the right null vector. And similarly, if U transpose A equals to 0 for U not equals to 0, I should write it as transpose, then U is the left null vector. Is this definition clear?
No, sir.
No? Okay. So if you have a vector V which you multiply, which is multiplied by matrix A, it gives us a zero vector. These are all vectors. So by definition, if A into V is 0, but V is not the zero vector itself, that means V has some non-zero elements out there. Then V is the right null vector.
Okay, got it, sir.
Okay. Similar is the
Sir,
case.
why it is right null vector? I mean, why it is called
Because
like that?
yeah, right. Because if you see here the direction in which you multiply, so V is multiplied to the right of A, right?
Yes, sir.
And similarly, A is multiplied. U is multiplied to the left of A.
Okay,
Not.
got it.
U
Got
transpose is
it.
multiplied, so U is called as a left null vector. Yeah.
Instead of U transpose, it could have also been U, right?
Depends
Or
on
is
how
it
you
not?
define your vector, but here it's 3 cross 3, right?
Yeah.
So you have to have 1 cross 3 out here.
Okay, since vectors will be always column
Column
vector,
vector.
right?
Yeah.
Okay,
By our
okay,
convention, it's column vector, so
cool.
we take it as
Okay, got it.
okay. So we just need to find a vector where f into e is 0. Do you understand why do I write e here?
Yeah, it's epipole, right?
Yeah, it's the epipole in the
First,
Right null vector.
right null vector. Right,
no epipole in which image plane?
left image plane.
Yeah, left image plane. So one which of these could possibly be epipole? Just take one row of it. It's pretty easy. So you just need to multiply 20 into 3 and 12 into 5. 20 into 3 is 60. 12 into 5 is also 60. Which means what? They need to be in the opposite sign.
It will be C or D, sir.
Okay. So it will be C or D. That's true. Now since you have 1 out there, so you have to compensate. You have to check for the rows which considers 1 as well. So which one is that? You can just try multiplying it so it turns out to be C.
Yes.
Yes, sir. C.
Yeah. So the answer is C. Okay, yeah, someone is not able to hear me. I'm getting some messages out there.
बार बार बदस में एसिडिटी और गैस
Uh,
प्रॉब्लम आप है आपका कमजोर पाचन ये देखिए,
Excuse me, can you
जन्नों
please
खड़े हैं
mute your microphone?
करे सातों पाचन केंद्र को जड़ से मजबूत और 4 हफ्तों में पेट की तकलीफें कम करो पाचन स्ट्रॉन्ग याद रखिए लंबी रात के लिए 2 चम्मच सुबह शाम 4 Let's celebrate guys.
Okay, I guess this. Um, I think she has to check her volume. Can you check your volume? Others can hear me, right? I mean, there's no.
Yes, sir.
Yeah, yeah.
Yes, sir.
Speakers. Okay, by the time it's been checked, we should move on to the next question. Okay, today's questions seem to be simple, at least to me. I don't know. What about you people? Given given the right epipole E prime and point X prime on the right image plane of a stereo imaging setup, compute the epipolar line L prime containing the point X prime in the right imaging plane in the right image plane in the homogeneous coordinate system. So I hope the question is clear. We just need to find L prime.
Yes, sir.
Given the first question, what should be the answer?
E prime
E
cross
prime
X
cross
prime.
X prime.
Yeah, E prime cross X prime, where both are in homogeneous coordinates. Fine. Okay, this question is quite simple. We'll just move on to the next one then. Where is it? So we are given a fundamental matrix F. Okay, this is also simple, I guess. So we are given 2 points 5, 8 and 7, 5 in the left image. Compute the epipolar lines. Is it simple? Can anyone tell the answer? So we are given 2 points. Given 2 points.
E
Yeah, yeah. Tell.
E is the cross product of x1 and x2.
What?
E left image, like left epipolar, is a cross product of 2 points.
So I think first we have to calculate homography from the fundamental matrix.
How can you calculate that? Do you think it's always you can calculate a homography always?
No, sir.
Under which conditions can you compute homography? Just two of them was discussed in the class, and one of them we saw. I mean, both of them we saw in today's tutorial as well. What are the two conditions under which we can compute homography? One is pure rotation.
Pure rotation or pure translation?
No, not pure translation.
Uh, ro-
So one is this pure rotation one, which we solved in the second question.
Yes, sir.
In this case, we can have a homography here, H, and the other one in the first question, where if we see a planar scene, we can compute a homography. Other than that, uh, apart from degenerate cases, in general, you cannot have homographies.
Okay, sir. So we need a stereo system for calculating the homography.
Yeah. So here there is no question of homography. I mean, out here. So you're given fundamental matrix, and you need to compute the epipolar lines. That's all. So if you are given something like this, you're given a matrix F and 2 points here, x1 and x2. Assume that this is E prime. So this will be line 1, which will contain x1 prime, and this will be line 2, which will contain x2 prime. Okay.
So will x1 prime line like L1 will be f into x1?
Yeah, that L1 prime is this line.
Yes. And then we can check the intersection points of the L1 and L2 to get the input.
Okay, first of all, first whatever you said was right. L1 prime is f into x1, L2 prime is f into x2.
E prime will be L1 prime cross L2 prime.
E prime is fine. Yeah, you don't have to find E prime. Here they just asked us to find the epipolar
Okay.
lines.
Okay.
So our answer is just this. Yeah, if you
So
want to
epipolar
find, yeah, yes, yes,
so epipolar line can be any of the lines, right?
yes, yes,
Both
yes.
both lines are epipolar lines.
Yeah, both lines are epipolar lines. So for a given point x1, the epipolar line is L1 prime. For a given point x2, the epipolar line is L2 prime.
Got it.
And all epipolar lines intersect at E prime. So now you can always find if you have another point x3, you can always compute that corresponding epipolar x3 prime. If you then you can always compute the corresponding epipolar line as E prime cross x3 prime.
Yes, sir.
E prime cross.
X3 prime. So if you have
Okay.
given these 2 points, then you can always find this specific epipolar line.
Okay. Yeah, yeah, correct. Correct.
That's all. Okay, so yeah, there is nothing more to this question. It's just realization that the lines can be written pretty easily, fx1 and fx2. That's all. Okay, fine. We'll move on to the next one then. Okay, yeah. The next question is given the same things, you just need to find the right epipole. How can you do that? Someone gave the answer.
Yeah, L1 percent
L1 cross L2.
dash.
Yeah, L1 dash cross L2. Okay, I'll just write out the answers in case if it's required. So our L, which question is this? L1 prime will look something like this: 21, 13, 13. L2 prime will look something like this: -22, 2. And our E prime will look something like this.
So
Yes.
if we scale these things, scale this L1 prime of L2 prime, will there be any change or it will be same only?
What do you think?
If I write it as an equation, so there will not be any change, right? So I think there won't be any
How
change.
are our lines defined?
20, I mean 21x plus 13y plus 13z equals to 0 according to that.
Yeah, yeah. So
So if we take common and make it change, so no changes will be there, right?
yeah, yeah. So we write our lines like this, right? This
Yes.
red box. So any scaling of L or even X won't matter.
Okay, thank you, sir.
So just for our convention, I mean, since we are on the image plane, we take the third coordinate as 1 for the X. That's all. Okay. Yeah. So we'll move on to the next question. Where is this?
In the above question, the right epipole is in homogeneous coordinate system, right?
Yeah. You have to divide
Yes.
by 302.
302. So 0 minus 1.
Yeah. 0 minus 1, 1.
one. Yeah.
That's how equivalently you can write it as u minus u. Okay, yeah. So for the next question, uh, you need to compute the essential matrix given the calibration matrix K and K prime along with fundamental matrix F. Okay, what is the difference between essential and fundamental matrix? When can you derive which one of them?
Sorry, sir, but I had some. I couldn't understand this part of this part while
Okay,
listening.
okay. We will get to that. That's okay. But any just little bit of idea when can we compute essential matrix or when can we compute the fundamental matrix?
So I thought that essential matrix will be needed for when we are uh, we are getting the image to the infinite plane, to the infinite homography via the left camera and right camera. I mean, making a total calibration matrix and fundamental matrix together. That will be the essential matrix. I thought like that, but I couldn't.
Um, okay. Uh, that infinite homography, whatever you're saying, that's used for the definition of deriving the fundamental matrix, which is fine. But okay, practically speaking, what does it mean? Try to use the shapes. Okay, let this be the case. I'll explain this. Okay, so you're given two images. When you're given corresponding points x1, x2, x3, and x4, and their corresponding points here as well, x1 prime, x2 prime, x3 prime, and x4 prime. Okay, yeah. So these points, if they are in pixel coordinates, if x and x prime are in pixel coordinates, and you don't know anything more about them, then you can compute the only with this information you can compute the fundamental matrix. So if you remember x x prime transpose fx equals to 0. So given this and this, you have to get the fundamental matrix. Okay, so what is the dimension of fundamental matrix? It is 3 cross 3.
Yes, because
Number of parameters is number of
one
rather
scale.
degree of freedom. How many degrees of freedom does it have?
I think 7 degrees of freedom.
Okay, degrees of freedom is 7. How?
Because one is scaling factor and other one is
Property of fundamental matrix?
Determinant is zero.
yeah, that says rank deficient.
We
And
can create another equation.
Yes.
yeah, so given these two, so the degree of freedom is 7. So how many what is this equation? It's a scalar equation, right? Scalar equation means left side is a scalar
Sir, yes.
and right side is a scalar 0. Okay, so given this, when x and x prime are in pixel coordinates, you can compute the fundamental matrix. Where how did you obtain x or x prime? x is some p into capital X, and x prime is some p prime into capital X, which if you write as r p x, here you can write as r prime p prime x. So given a same 3D point x, you can get x and x prime like this, and then from there you get this equation. How many number of point correspondences x and x prime do you need? To compute the fundamental matrix? This was discussed in the class, right? Estimation of fundamental matrix. How many number of point correspondences do you need? Okay,
8.
8. Okay, why do you say 8?
So that the even I got confused because like in course it was mentioned 8, but the degrees of freedom was 7. So even I got confused there.
Mm-hmm. Okay. So since the degrees of freedom is 7, you can compute with 7 points. But generally what we do is we don't take the scaling factor into consideration. When you set up that a into f equals to 0, right? So we did not consider scaling factor explicitly. So we need 2n cross 8. Okay. So it is like 2n cross 9 into 9 cross 1. If you just directly convert this into this matrix. So the last one, when you fix it at 1, that means f33 is 1, then you can convert it into homogeneous coordinates. So you need only 8 parameters to be estimated. So that's when you get 8 points. So given those 8 points, you have to project it back onto this scaling determinant of f is 0. Is this part intuitively clear?
Yes, sir.
Okay,
So
so
it will
let's
be
try.
in general like degrees of freedom plus 1 point correspondences if there is a scaling factor involved.
No, no, no. For this specific case, when we are trying to solve,
Spec-
okay, I said the other way around actually. So we did not consider determinant of f equals to 0 explicitly when you try to solve af equals to 0, right? So if you write af equals to 0, there is no constraint on it. So first constraint that we try is to fix the scaling factor, which is by putting f double 3 equals 1, which is the last element. So if you do this, you solve it in a homogeneous fashion, or else you can do it in a inhomogeneous. Sorry, this is the inhomogeneous method. The DLT methods, the two DLT methods, inhomogeneous DLT. Else you can also do the same thing out there, where norm of f is some constant which is 1. Oh, this is called as homogeneous because the last one is okay. I'm sorry, I missed it. Yeah, this is fine. So this is the inhomogeneous DLT, and this, if you can put this constraint, this is the homogeneous DLT, where you can just try to find the singular vector of A through which you get the f. Once you get f, you need to project it onto determinant of f equals to 0, which can be done using SVD. So for estimation, you generally take 8-point correspondences for this case. Okay, so we were somewhere here. Yeah. So when you know these, uh, when you don't exactly know, when you only have x and x prime given to you in pixel coordinates, then you can estimate fundamental matrix. So I would write to like this as k into xc and k into xe prime, k prime into xe prime, where xe is rtx and xe prime is given as r prime t prime x. Okay. Uh, I'm just rewriting xc so that it becomes more clear. When you have xc and xe prime given to you, so which are, you can say that in canonical coordinates. Canonical coordinates means that the k, you can assume it to be, I mean, it is corrected for k. K is corrected. So then you can estimate the essential matrix.
Oh, canonical means R will also be identity matrix, right?
I'm not talking about canonical camera. I'm just talking about
Okay.
canonical coordinates in the image plane. That's all. I'm not
Okay.
talking about the 3D coordinate space here. I'm just talking about the 2D coordinate space, the image plane, on the image plane. So that's what XC is referred to in the lectures as well. So it is in the canonical coordinates. Canonical in the sense that you can always, so from here you can see that k equals x equals to k into xc. So if you want to get canonical coordinates, you can just invert the matrix and then get it. Invert the intrinsic matrix and then you can get this. Similarly, you can invert the intrinsic matrix in the other image and get the canonical coordinates. So what do you mean by this canonical coordinates? So if you remember, so here you have some alpha x, alpha y, here there was some s, here uv 001. So in canonical coordinates, when you have it, so you have corrected for the calibration matrix. Corrected for the calibration matrix means that u comma v will be 0. That means it will be on the center of the image plane, and the focal length will also be corrected to 1. That means it will be somewhere similar to the pinhole camera. S should be 0. Is this intuition clear? That from
Yeah.
a general
Yes.
focal length and general coordinate system which has uh,
UV as
origin
the center.
uv as the center, we convert it to a coordinate system where the origin itself is the center and focal length is 1. So that's why it's called as
Yes.
canonical coordinates. That's how the name
So
comes.
okay, then we'll say that K is an identity matrix.
Yeah, then we can say that k is an identity
Uh,
Okay,
so
got it.
so we have to take every for changing this thing K as an identity matrix. We are changing all these points
yes
accordingly, right?
yes. So here, yeah, so you can say that to obtain canonical coordinates, you don't have to multiply with k, or in the other words, you can just convert from your original coordinates to the canonical coordinates by inverting k. That's all. Two different ways of seeing it.
Yes. Okay.
So okay. So just I'll try to derive that. X prime transpose fx equals to 0. So we know that x prime is k prime x, right? Derive that. Oh, sorry. X prime is k prime xc, x is kxc. That's what we wrote earlier. So given this, we'll just replace it. K prime xc transpose f and x is kxc should be 0. xc prime, sorry, xc prime transpose k prime transpose f k xc equals to 0. So this is our essential matrix C, which is given by k prime transpose f k. So we are given in the question k prime and k and f as well. So we can derive the answer. It's just matrix multiplication. Fine.
Yes, fine.
Okay. Do you see anything wrong in this question?
Just sir, what is the difference, actual difference between intuitionally between fundamental matrix and essential matrix? Intuitionally, what is the difference?
Uh, Sorry, I did not get you.
What is the difference between a fundamental matrix? I mean, what the
Okay.
question you asked, the basic
No, no,
initially. That
no, no. That's okay.
different.
So you got the difference, right? So when you have
Yeah.
calibrated cameras, that means
Yes.
when you know K, we just want to remove the problem with K. So you can get
Yes.
it
Yes.
into canonical coordinates. So you get an essential matrix.
So just to fit into canonical coordinates and making it easy, that's why essential matrix is used,
Yeah,
right?
yeah, yeah. So, we, so ultimately, this looks like xc transpose E into xc equals 0. So this essential matrix relates, uh, E relates in canonical coordinate system, canonical image coordinate system rather, not the whole coordinate, canonical image coordinate system. And here F relates in general image coordinate system. Okay, that's fine, but my question was something different. Do you see anything wrong in this question? Do you think that camera K, left camera K intrinsic matrix is correct? Hmm? Or someone saying anything?
Is it at the origin, like at infinity, like camera? Because
Um,
the last row is zero completely.
Last row is 0. I mean, camera intrinsic matrix should be invertible. So
Okay,
that camera matrix is not correct. So it's
not.
this part should be 1. That's all. If you remember, if I wrote something like this, the form should be like this.
Yes.
It's an upper triangle matrix. So the last element is 1. Any scaling factor doesn't matter because we are in projective space, but it should not be 0. That's all. Okay, on to the next question. Okay, I guess this one is good one. So again, since we are in stereo lectures, we'll have questions from stereo. So we are given stereo imaging setup with two cameras, P and P prime. Which of the following options are correct? Okay. Okay, so first we'll try to find the right epipode, which I think is relatively easy. What is right epipode? E prime. E prime into C, right?
Yes, sir.
Yeah, where P prime is the. I mean, we are just trying to image.
The center.
Yeah, image the center, image the first camera on to second image. So what is C? P is given to you. Oh, sorry, P prime. One, two, three. What is C? You are given P like this, right? If you remember, P is of this form, right? From the
Yes.
previous lectures.
Yes, sir.
So from this you can take it like this, right? A is I, R is I, C tilde is 0, right?
Yes, sir.
Okay, then here it should be C tilde, where C tilde is 0, 0, 0.
0, 0.
So our epipole E prime is 1 to 1. Is this fine? So this is the right option.
Okay,
Now
sir.
let's check the fundamental matrix F. How do we derive the fundamental matrix given to camera matrices P and P prime? Does anyone have an answer for this? So do you remember the formula or any derivation? I would recommend that you learn it the way it was derived rather than remembering the formula. Otherwise, there are too many formulas to remember.
So we need to solve more problems, right, sir?
Sorry?
Like, because this is like first time we are learning all this for first time. So all the derivations, if you want to get used to, so we need to do more problems, right?
Okay. Uh, that's okay. That's fine. But do you remember the formula then? Because if you don't
No,
know the
sir.
formula, then there's nothing much to this question. The point is in exam,
Yes,
generally,
sir.
at least for me, it's pretty hard to remember the formula. So if you just stick with the
Same, sir.
basics, if you stick with the basics, this is just three-line derivation. That's all. We are not deriving any hi-fi stuff out here.
Yes,
So
sir.
that's why I try to keep it a bit of derivation before I just write the formula. Okay. Uh, so you remember these two basic equations, right? If I just write it this way, these are just the projection equations. Now x can be written, sorry, the x can be written as, from this case, e dash, sorry, e dash x, sorry. So from this, what can we get? X is p pseudo inverse x. It's 3 cross 4. This is 4 cross 1. This is 3 cross 1. I hope these things are clear.
Yes, sir.
Yeah. So we get x prime is p prime x. P prime is what? P prime we don't have to remove, but we can just replace the capital X like this. P pseudo inverse x. With this, what can we get? This is the homography that someone was saying. P prime
At
P pseudo
infinity.
inverse x. So this is x prime. Okay, so now if you again, let's too many formulas to remember. So what can I do? If I remember the diagram, then it's even easy, right? So what do I know about this? This L prime is E prime cross X prime, right? Or someone was saying that we can write it in matrix form, E prime cross into X prime, where this is the skew symmetric matrix form. Now what do you know about X prime? X prime is E prime cross H
P
pi into
prime
X.
X.
Yes. So given, we'll just try to solve it for our specific case. P prime pre pseudo inverse. What is P prime in general? If we take it in this form,
Mm.
MM,
Yeah.
and P pseudo inverse is some other MM, but okay, let's consider P as the canonical one. For our question, it holds, right? It's just identity and zero. So
Yes, sir.
P, yeah, so P is the canonical camera. So given this, I can write it as identity and a zero row. If we multiply this, what do we get? We get M. Fine.
Yes, sir.
So H pi is pen M. So what do we get? L prime is E prime
EX
cross H
M.
pi, which is M. Now we know that X prime. Uh, okay, X prime will lie on. Where is
The
it?
epipolar line.
Yeah, this is M into X. Sorry, L prime is this, right? E prime cross H pi into X. So H pi is M. So L prime is E prime cross MX. Okay. X. So with the point containment relationship as told in the class, X prime will lie on L prime. This will lead us to L prime transpose X prime is zero, or the way it's written in the class, or in general it's written like this. We just replace L prime with that E. This is X prime transpose E cross M into X is zero. So this is how I get the fundamental matrix F. So it's just 2 minute derivation, not a big deal. So it is E prime cross M. Okay, we got E prime already above. Yeah, this which is 1 to 1. And what is M out here? M is this matrix.
Identity matrix.
No,
Sorry, 1 2 5.
yeah, this one. 1 to 5, 2 double 0 3 0. So given this, this will be the answer, by the way. Just cross multiply.
Sir, can you explain that P plus once again?
Oh, P
The
pseudo
pseudo
inverse.
inverse.
Okay, okay. P pseudo inverse. Okay,
Okay.
fine. P, it is not plus, it is the symbol
Ah,
that's used by Christians. I forgot the name. So what P pseudo inverse does is, if you have something of this kind, so it should give you an identity matrix 4 cross 3. So it should give you some sort of identity matrix. Why is it pseudo inverse? Because it's not a square matrix. P is not a square matrix, so it is not invertible. So we try to take a matrix such that its multiplication will give us an identity matrix. That's all. That's how it's named as pseudo inverse.
okay.
So this pseudo inverse. So it is not the actual inverse, but a proxy inverse. That's why we call it a pseudo inverse. So in our case, P was pretty simple. I 0. So P pseudo inverse is just try to take the inverse of this identity matrix, and we know that by inspection here itself, multiplying these uh, 0 vector with any vector actually gives
Okay,
us
come on.
0. I mean, it doesn't matter here.
So it's always a zero in the P, like P pseudo inverse, and like at the bottom, is it?
Yeah, you can. I mean, for this case, you can take it as 0.
Okay.
So is this question clear? I mean, it's just
Yes,
Yes,
sir.
sir.
we
Yes.
derive the formula. That's all. Nothing more to it. But I hope you are able to understand how to remember this instead of just remembering the formula. If you remember it geometrically, it becomes easier to
Yes, from the
handle.
diagram, sir.
Yeah, diagrams and basic relations. Okay, then. Um, I
Sir, like this week, so is there any like practical like application that we can build? Like,
oh, this week's great
huh?
stereo camera. Come on.
Yes, sir.
Which phone do you have?
Realme 3 Pro.
How many cameras does it have?
Two.
Okay. So why do you think you have two cameras? What effects
Okay.
can you make use of the phone? There are
Uh,
different effects that you see nowadays. One of the effects which is useful here.
okay, like the black and white filter and like
No
filter
filters.
that
I'm
you have
not.
not.
Yeah, okay.
Okay.
It's. I mean, okay. I will not say it as a
So
filter.
the projection, the distance between the cameras are less, though the image is very clear. But according to this thing, if the distance increases, then the projection will be like pinhole projection. Otherwise, there will be distortion.
Okay, that's okay. But I'm talking about the application part. What you were saying. So you have multiple cameras nowadays in phones, right? So if you remember, we can compute depth if you're given
Yes,
two
sir.
cameras,
Yes,
right?
sir. Yes, sir.
That was given by disparity, if I remember correctly. In the class, it was given disparity. There was a formula for disparity, right?
Yes, sir. It was.
So kt by something x minus x prime. So x
Yes,
minus
sir.
x prime is the
Is
disparity
the
from where
Yes, yes, sir. Yes, sir.
you get the depth. So if you see the portrait effects that you generally use for selfies, not selfies, no selfies. I would not say that. It's some sort of other processing, by the way. So if you want to take portrait effect from the front camera, sorry, back camera. So you have two cameras now. So you can estimate depth, relative depth, easily.
Okay.
You can
So
actually
one
estimate the
camera will
actual
be
depth. Yeah, one camera is the canonical camera you can consider. The other camera you can it's shifted by in x coordinate or in y coordinate. You can take it that way. And given that, you can compute depth. With this, you can estimate depth from where you can have the portrait effects and all.
okay.
One of the applications. There are many more.
But because we are not able to map it, so if we map, so then we'll be able to easily understand the topic.
Yeah,
So
so
that's why.
computer vision is something that you can easily relate to because you can visualize everything. And nowadays, everyone has cameras, so just simple Google search can help you a lot.
Yes, sir.
I probably even I don't know the all the
Okay, sir.
applications,
Thank you.
to be frank.
Okay.
Yeah.
Okay, sir.
Thank you, sir.
Okay. Yeah. Then. Okay.
So,
Thank you.
sir, have you
Yeah,
go
I'll just
through
stop
the
the
whole
recording.
12 weeks content, sir?
Yeah, I'll just stop the recording.
Okay.